Good morning again. We're just going to finish 11.2 today. This is 11.2 part 2, which is called Simplify Radical Expressions. Now yesterday we talked about the product property of radicals. How do we multiply square roots? Quotient property of radicals. How do we divide square roots? We learned to rationalize the denominator, aka get rid of the denominator in the square root as the denominator of a fraction. And today we're going to work on adding and subtracting radicals and then multiplying radical expressions. So just as a reminder of what we did yesterday, I'm going to try guided practice 4. And that's just as a refresher. Say I have 1 over the square root of x. I have a problem. I'm not allowed to leave a square root in the denominator. So what do I do? Well, from what we learned yesterday, if we multiply 1 over the square root of x times the square root of x over the square root of x, which means multiplying by 1. On top, I'm now going to end up with the square root of x, but on the bottom, I'll end up with the square root of x squared inside the radical symbol. And I know that square root of x squared is x. So 1 over the square root of x, when I rationalize the denominator, ends up being the square root of x over x. Okay, that's just a quick review. But let's go a little further in the lesson, and we're going to go into example 5. So we've multiplied and divided radicals. What happens if you want to add and subtract them? So let's have 4 square root of 10 plus the square root of 13 minus 9 square root of 10. What you need to do with radicals is basically pretend that they're like variables. So I'm going to make the square root of 10 in green and this square root of 10 in green, right? Because they're really the same thing. And this square root of 13, I'm going to put in red or red-black since I have a lot of black. And it's a little bit like, say I had 4a plus b minus 9a, right? Because here a and a are the same, right? They're like terms, and b is slightly different. So what you're doing when you're adding and subtracting radicals is you're basically adding and subtracting like terms. And 4 square root of 10 and negative 9 square root of 10 are like terms because they're both multiplied by the same number. So I end up with 4 square root of 10 minus 9 square root of 10 is negative 5 square root of 10. Because I've combined those like terms with the square root of 10. I'm just going to keep that green there to remind myself why I was allowed to do that. But the square root of 13 does not have a like term. So it's going to be plus the square root of 13. And that's my answer. I can't simplify that any further. So if you're adding and subtracting radicals, it's sort of like adding like terms, with the square root acting sort of like a like term or a variable. So let's look at part B. Five square root of 3 plus the square root of 48. Okay, and I want to add those together. Well, the thing is, I don't have like terms. Square root of 3 and square root of 48, they're not like terms. But I also noticed square root of 48 is not fully simplified. So I really can't quite make that decision yet because it's not fully simplified. So I need to simplify this first. So I'm going to keep this because this 5 square root of 3 is as simplified as it gets. But the square root of 48 is the square root of 16 times 3. Well, that means 5 square root of 3 plus the square root of 16 times the square root of 3. Well, I've learned how to simplify expressions like that. Square root of 16 is 4, and I leave the square root of 3 here. And I'm adding that. I've just carried the 5 square root of 3 down. Don't neglect doing that. Now I have like terms. I have 5 square root of 3 plus 4 square root of 3, and I'm allowed to add them. And when I do, I get 9 square root of 3. Okay, so I would like you to try 2 problems. I want you to go down to guided practice 5 and 6. Guided practice 5 is a reminder of rationalizing the denominator, so you're going to try that. And guided practice 6 is adding and subtracting radicals. So try those right now, pause the video, and then come back and see if you did it correctly. Okay, guided practice 5, and I've written that too high. I'm going to lower that down. There we go. So here's our problem. I have 3 divided by square root of 2x. Well, I can't have that square root of 2x in the denominator. So I'm going to take 3 divided by 2x and multiply it by the square root of 2x over the square root of 2x. When I do that, I get 3 square root of 2x in my numerator, and square root of 2x times square root of 2x is square root of 4x squared, which is going to mean 3 square root of 2x over 2x, because I can, the square root of 4 is 2, and the square root of x squared is x. So you should have gotten 3 square root of 2x over 2x. Okay, now then let's look at guided practice 6, which is a practice of adding and subtracting radicals. That is 2 square root of 7 plus 3 square root of 63. And just like the last example, which was example 5b, you can see that 3 square root of 63 is not as simplified as it can be. So I'm going to copy 2 square root of 7 over because that can't be made any simpler. And let's see what I can do with square root of 63. Well, that is the square root of 3 square root of 7 times 9. And that equals 2 square root of 7 plus 3 times the square root of 7 times the square root of 9. Well, the square root of 9 is just 3. So I end up with 2 square root of 7 plus 3 square root of 7 times 3. Well, this 3 is multiplied by this 3. So I'm going to end up with 2 square root of 7 plus 9 square root of 7. I now have like terms. I had something multiplied by the square root of 7 and something multiplied by the square root of 7. So I'm now allowed to combine those, and I get 11 square root of 7. And hopefully that's what you got also for guided practice 6. Okay. So I'm going to move on to examples 6 and 7 in the next video.